In this section, we're going to talk about prime numbers and prime factorization. Prime number is a number that has two factors, one in itself. The composite number has more than two factors. The number 1 is not a prime number. It has only one factor. It is neither prime nor composite. Determining whether a number is prime or not is done by figuring out whether any numbers go into it. So if you can divide a number into it, and it goes evenly, then you know that it is not prime unless that number is just itself. So the number 2 is prime because the only number that goes into 2 evenly is 2 and 1. That's what makes it prime. 3 is prime, 5 is prime, 7 is prime, and 11 is prime, so forth and so on. Our remainder is 0, therefore it's a prime number. If you find that your question is smaller than the prime divisor, that means that it's a prime number because it has no smaller number than prime factors. Every composite number has exactly one prime factorization. That's the fundamental theorem of arithmetic. Finding the prime factorization of a composite number, you simply factor that composite number into any two factors. So if we had the number 60, we would say what two numbers can make up 60? So for example, we could say 6 times 10 gives you 60. And then we'd say, let's factor each of these two numbers into numbers that are factors. So factors are whatever numbers can go into that number evenly. So numbers that go into 6 evenly would be 2 times 3. Numbers that go in that make up 10 would be 2 times 5. 2 is a prime number, 3 is a prime number, 2 is a prime number, 5 is a prime number. That makes its prime factorization 2 times 2 times 3 times 5. They generally like for it to be in numerical order. Now that you have learned about exponents, they might want it to be in an exponential form. So they might say, since you have 2 2's, you can write it 2 squared times 3 times 5. It is never given in the book, but this is a list of prime numbers. You do not have to memorize the list. It's convenient for you to have around. That's the best I can do. Please remember 1 is not a prime number, therefore it's not on the list. This list goes all the way up to 50. So these are all the prime numbers between 0 and 50. Feel free to pause the video. Factors of a composite number. You could have 1 in the number itself, that would make it prime. You could have each prime factor. You could have the products formed by all combinations of prime factors. So, they wanted us to find all the factors of 60. Oh, they shouldn't have said it that way. Okay. So to find all the factors of 60, we're not going to do it the way the book does it. They want to know every number that goes into 60. They didn't ask for the prime factorization, which is what we found the page before. So I'm not trying to break down 60. I'm starting with every number that goes into 60. So I'm going to start listing them out with 1 times 60 being my beginning. And then I'm going to go in order with every number that can go into it. Does 2 go into 60? Yes. 2 times what number? Not 60. 2 times what number gives you 60? 2 times 30. 3 goes into 60. 3 times 20. Does 4 go into 60? Yes. 4 times 15. Does 5 go into 60? Yes. This is why you do the divisibility stuff. 5 goes into 60 12 times. If you need to use your calculator, you can. 6 go into 60? Yes. 6 goes into 60 10 times. 7 go into 60? No. 8 go into 60? No. 9 go into 60? No. 10 go into 60? Why, yes, we already have it written down. As soon as you loop around to the other side of this list, you're done making your list. That's why I list them this way. As soon as you cross over to the other side, you're done. And you can list them out. 1, 2, 3, 4, 5, 6, 10, 12, 15, 20, 30, 60. Those are the factors. If we wanted to do 42, we start listing. Always start with 1 times the number. Then go to the next number. Does 2 go into it? Yes. 2 times what? 21. 3 go into it? Yes. 3 times what? 14. Does 4 go into it? No. Does 5 go into it? No. Does 6 go into it? Yes. 6 times what? 7. 7 go into it? We've already got it on our list. So we're done making our list. So I can start writing them out. When they say find all the factors, that's when you do this. When they say find the prime factorization, that's when you break it down like a tree. Determine whether each number is prime or composite. If the number is composite, find at least 3 factors of the number. 47 is on our list, so it's prime. 63, 3 goes into. 63 is not on our list. Wouldn't be anyway because it's less than 50, but 63, 9 goes into, 7 goes into, so it's composite. They want 3 factors. 1 is one of my factors. 63 is one of my factors. They work. And then 7 can go into it. 9 can go into it. Those are the factors of 63. Prime factorization for 125. 2 numbers that multiply together to give you 125. Well, 5 goes into it. So I'm going to say 5 times 25. You know how I knew it was 25? Could say 125 divided by 5. Because I knew 5 went into it because it ended in a 5. Since 5 is prime, I can just drop it down. 2 things that multiply together to give you 25. 5 times 5. I used to have students that when they got to a prime number, they just circled it. And that way they'd know that the primes were the ones that were circled. So 125 is 5 to the third. 150 15 times 10. It's 5 times 3. They're both prime. 2 times 5. They're both prime. 2 times 3 times 5 squared. Ooh, let me look and see. They do want you to use exponents. Thought I should let you know. Let me know if you have any questions on this or on anything else that we've done. And that should end chapter 1. We'll work on chapter 2 later.